Part of what it means to be human is to imagine and anticipate, to think through likely courses of action, to think through possible plans, what might go right and what might go wrong. But there's a big difference between assessing risk, which is something we do naturally, and risk assessment, which is a formal policy that we put in place for the estimation and management of risk. We do risk assessment when we travel. We do risk assessment when we go into schools. We do risk assessment when we design planes, and we do risk assessment when we form policy. Why? What do we hope to get out of moving from that natural human instinct to anticipate the future to a formalised process for the study of risk? That's what we're going to have a little chat about now. This is the result of risk assessment. What you're looking at is, in fact, Columbia. It's a space shuttle in many, many pieces, despite one of the largest risk assessment and risk management processes in the world. So what went wrong? Well, physically, what happened was a piece of foam, this thing you can see up here, fell off and struck the wing, as you can see here. Now, when I say foam, I mean quite literally. This is the stuff that you pack when you buy a new washing machine. It's very lightweight stuff, but when you have a space shuttle on launch, it moves very, very fast and can cause a lot of damage. Now, this foam had been known to fall off. It had fallen off multiple times on previous flights, and the wings were known to take damage. They were known to take damage to the point where they had dedicated software tools for modelling and assessing the likely size and extent of any sort of impact damage. So how do we explain the fact that we have a known hazard, we have a complicated process for risk assessment, and yet we have an accident? Well, there are a few things that we could use as possible explanations. We could say, well, they knew about it and they didn't do anything about it. Therefore, it was genuinely an acceptable risk. It was something that they shouldn't have worried about, that they shouldn't have done anything about, that this is just what happens when you fly into space, is sometimes falling bits of foam kill your astronauts. The second hypothesis is that we could say, well, they didn't do enough to assess the risk. They should have done more to think formally about this, more to analyse it, more to understand it. And the third possibility is that it was a real risk, that they did enough to assess it, they were just unusually bad at it. And as you can guess from the slide behind me, we're going to reject all three of these hypotheses and see what else we can come up with. So to start with, was this an acceptable risk? Well, before this particular flight, they estimated that there was a 1% chance of the foam falling off. And after the flight, they made significant changes to the way they managed both foam and general debris. Now, it wasn't true that there was a 1% chance of foam falling off. Foam had fallen off on multiple previous flights, and there'd only been 100 or so flights. And it wasn't true that foam falling off was acceptable, because clearly the fact that they made changes means that they did not consider this to be a normal, acceptable thing to happen. So the size of the risk was clearly not understood. So not a genuinely acceptable risk. Did they do enough to assess the risk? Well, when they first designed the shuttle, they did a safety analysis of it. They did post-flight assessments after every single flight. And 4 of these assessments specifically looked at and discussed the issues related to foam falling off and things hitting the wings. Before they launched each flight, they had pre-flight safety briefings. And these specifically discussed the risks that had been identified in the post-flight risk assessments. During the particular flight that was destroyed, they had a dedicated debris assessment team who were making use of dedicated debris assessment software. A special team put together using special software that they didn't do on the fly, that they had already done. So clearly this is something that they had thought about in the past. It's a little bit hard to say, well, they didn't do enough, because the expectations on NASA if we transfer those expectations to anyone else, would be more money and effort spent on this one particular hazard than your average organisation spends on their entire safety program. So let's rule out the fact that they didn't do enough to assess the risk, and we're left with the fact that maybe they were just really bad at it. Well, here we just have to look and say, well, who else does risk assessment, and how's that working out for them? So this is the Deepwater Horizon, large oil rig off the coast of New Mexico, largest oil spill in the world. And there is a specific dedicated device on oil rigs when you have a blowout, when you have oil gushing up the pipe, called a blowout preventer that is meant to cut things off. The blowout preventer on Deepwater Horizon failed. The risk assessment for the blowout preventer is about 300 pages of detailed engineering analysis. This is the home insulation scheme in Australia. The basic accident here is that we had multiple contractors who suffered injury or died while installing insulation. There are a couple of different causes. There was electrocution, typically from stapling or nail gunning through into electrical wires, and from heat exhaustion. As part of setting up this team, there was a dedicated risk assessment program. They called in risk management consultants. They had numerous risk management workshops filled with stakeholders. So I don't think you can say that NASA was unusually bad at assessing risk, because this happens time and time again. We have accidents where you go back and look at the extent of risk assessment that was done, and you realise that there was no lack of risk assessment, just a failure of that risk assessment to successfully point out how bad things were. So we could change the hypothesis slightly and say, well, maybe this is just an explanation for accidents. Maybe when we have good risk assessments, we don't have accidents. Maybe when we have bad risk assessments, we do have accidents. So let's say it's not NASA. Let's just say that organisations with disasters in general are unusually bad at assessing risk. So here's the way that particular hypothesis would look. We've got two broad situations, one in which risk is acceptable, one in which it's unacceptable. And we have formal risk assessment as a process for telling us which is which. Most of the time it gets it right. It says that acceptable risk is acceptable, and it says that unacceptable risk is unacceptable. Occasionally it gets it wrong, and it says that unacceptable risks are in fact acceptable, and that's where we have accidents. Now, let me give you a different possibility. What if risk assessment is not in fact a truth engine, but a belief engine? So in fact, we start with not two situations, risk is acceptable or unacceptable, but two beliefs. We either believe that risk is acceptable, or we believe that risk is unacceptable. We go through a risk assessment activity, and what it does is it records and formalises that pre-existing belief. It tells us in a formal way that our belief that risk was acceptable is acceptable, and it tells us in a formal way that our belief that risk was unacceptable is unacceptable. It captures our previous understanding, but it doesn't have the power to change our minds. In fact, it's very rare to go from believing that risk is acceptable, doing a risk assessment, and coming out at the end believing that risk is unacceptable. It's likewise very rare to find that start believing that risk is unacceptable, do a risk assessment, and convince yourself that things are actually okay. And we know it's rare because these dotted lines, finding examples of risk assessment that actually do this, are very, very rare indeed. Risk assessment seldom actually causes people to change their minds about risk. So we're introducing here a concept. And full disclosure here, we're moving now from a general phenomena into talking about some of my own research, called probative blindness. Now, probative blindness is just a name to capture this fact that we have safety activities, typically risk assessments, and we believe, or at least our processes say, that these activities are designed to create information. They're designed to help us analyse and interpret, typically, risk. But the activities do not, in fact, change organisational beliefs at all. We think that these activities are truth engines, and it turns out that they just capture what we currently believe. So, in order to analyse this further, we looked at 4 particular examples. We looked at Columbia, the shuttle that we showed at the start of this talk. We looked at Deepwater Horizon. We looked at a series of incidents involving lithium batteries that caught fire on the new 787 planes. And we looked at the home insulation scheme. We had a look for each of the safety activities that were reported during those programs. And we looked whether there was any evidence that organisational beliefs had changed before or after. Now, for some of the activities, there was evidence that they had changed belief. For others, it was very clear that the beliefs after the activity were the same as the beliefs before the activity. And we had a look at what were the things surrounding those activities that didn't succeed in changing the organisation mind. So, first thing we can look at is characteristics of the activities themselves. How did the failure to change belief actually happen? Some of it was reported in the accident reports as simple errors. So things like hazards that existed that were never identified, or methods that were not really capable of analysing the hazards. Second thing we see is incorrect attribution. So what happens is the person doing the activity finds a problem, and their immediate thought is not, aha, there's a danger with the system. Their immediate thought was, oops, I must have done something wrong. So they go back and they fix the risk assessment so that it gives them the right or acceptable answer. The extreme case of this is double dipping, where one person does an activity, it gives an answer that people weren't expecting, so they go back and they do the activity again, or they ask a different person to do the activity, or they do a different activity to analyse the same problem. And always in these cases, they accept the answer of the second time, not of the first time. Even though there's no particular validity reason to pick one over the other, it's always the last one. It's always the one that gives them the answer that they want. The third thing we see is motivated skepticism. So it's not the case that everyone in these organisations thought that things were completely safe. But the organisations as a whole did believe that they were safe. So what happened was the people who came up with unfavourable answers were argued against. People were very happy to pick holes in risk assessment that didn't give the answers they want. People were very happy to talk about the limitations of experiments that revealed danger. People were always happy to talk about the competence or incompetence of the people doing activities that came up with the wrong answers. But if the activity gave the right answer, you don't see anyone questioning the competence. You don't see anyone questioning the limitations of the activity. You don't see anyone saying, go back and do that more thoroughly. And then the final thing we have is a difficulty in communicating uncertainty. So we have quite complicated reports that give a large amount of detail about confidence, a large amount of detail about what can and can't be concluded. So a typical answer is we say, well, we don't really know, but to the best of our knowledge, it's safe. And what people hear is safe. They don't hear, we don't really know. And so they focus on the probability, but not on the uncertainty. So what causes this to happen? There are a number of cases we can see that sort of exaggerate the likelihood of this happening. The first is strong prior beliefs in safety. People are sure that the system is safe, people are sure that the situation is safe, and so the reason they're doing the risk assessment is really just to confirm what they already know. We can see this quite clearly, for example, in the documents talking about the Nimrod crash. The Nimrod safety case was prepared shortly before the crash, and it was prepared in the sure knowledge that the system was in service for 30 years, had been safe for that entire time, was a trusted system, but we needed to produce the evidence to back that up. The second thing we see is a transfer of intent from safety to compliance. In each of these accidents, the word compliance appears an incredible number of times. People were not genuinely trying to make sure the system was safe. They were genuinely trying to make sure that they complied with the safety requirements or the safety program requirements. The third thing we see is success framing as no problems found. The risk assessment was performed successfully, as in we got the answer that we needed. The safety program was performed successfully, as in we've successfully convinced the regulator or the customer that the system was safe. No one talks about the success of safety the other way around. It was a successful safety program because we found a problem. It's always success means no problem. The third thing is we see a desire, very often communicated from senior leadership, to achieve certainty and closure. To move from things that are complicated and unsure to things that are very sure. Just tell me simply, is it safe or is it not safe? Give me an answer. That's the type of thing that we see that leads to risk assessments that give an answer of, yes, it's safe. Sometimes we see that there's simply insufficient capacity. The techniques or the people really lack the ability to interrogate the system or the problem to the extent that's needed. Or we see a separation between safety and non-safety. There's one group of people that are doing design or doing operations or doing the real work. There's another group of people whose job seems to be just to produce safety. And by producing safety, we mean producing safety documents, producing safety assurance, producing that certainty that it's safe. And there's a separation between those two groups. They hardly talk to each other. They communicate through documents rather than sitting in the same place. And there's a time delay between one activity and the other activity. And then the final thing we see is situations where even if the safety activities did come up with problems, no one would be able to do anything about it. Typically, this is because it's too late. Even if we found problems, our safety program has already used up most of its money on risk assessment. We don't have any budget for going back and doing redesign. We don't have any time for going back and doing redesign. Look, here's the lovely schedule we produced. It says design, it says test, it says safety assurance, and there's no gap at the end for what if the safety assurance finds any problems. So under these conditions, we very often see risk assessment which is capturing belief rather than causing change in belief. So this is something that we can see fairly easily in accidents. It's very easy to go back and look in hindsight and say, look at all these times that it's happened. But the conditions, those things that cause probative blindness, those are things that are really quite common. Those things are common in very many programs, in very many designs, in very many operations. So the real question is, how common is the phenomenon itself? How commonly does risk assessment or safety activity confirm existing belief or change beliefs? And we don't really have the answer to that. We just have a rather large and rather scary question.